If I gave you this one, which side would you box in? Okay. How can I get there? What do you want to try? We could. So it would factor into secant theta minus 1 and secant theta plus 1. Does that get us closer to where we're going? Not really, but that's part of it, right? You don't just look at it and know the right answer. Like, you try something, and you're like, that really didn't help. Is there another option? Okay, what if we did that? What if instead of factoring, so we tried it, it didn't, nothing magically canceled, so maybe that wasn't helping a whole lot. Secant squared minus 1 is tangent squared. Okay. Okay, sines and cosines. So this is what you have to know. The reciprocal of secant, that secant is 1 over cosine, right? And since it was squared, it would be 1 over cosine squared. How would I write tangent squared in terms of sine and cosine? How do we divide fractions? Notice I'm writing my squares on everything. I'm putting my thetas on everything. We're really working on good notation here. What happens? So I'm left with 1 over sine squared theta. And that is secant squared theta, which is what we wanted. Try another one. These two sides are practically identical. So we just have to pick one to work with. I would say the simpler side might be where they're multiplied, where it's a single term. So maybe I would box that in, not that you couldn't work from the other side, but maybe this will be easier. All right. Any thoughts on what we could do? Okay. Tangent squared would be sine squared theta over, or sine squared x over cosine squared x. Look at our goal. We want things multiplied, right? So I need to put these together. This is like a sine squared over 1. What do we have to put those together then? Common denominator. What would I have to multiply this one by? Okay. Now we have that common denominator. We can put them together. it doesn't really look like we're closer, but we are better off. It's all in one big fraction. If we look, we want things multiplied. Any idea on how I could get that? That might work. That will work, but it's going to be a longer path. So we can do that. Huh? Split the fraction up. Now we have to be careful. We don't want to just undo where we were at, right? But I agree we need to split it up. So you guys are really close. Look at this numerator. I have two terms. What do they both have? What if I factor that out? Okay. This is all one term now, so we could split it up however we like. Since they're multiplied, only one of them has to be with the denominator. So I could put like the sine squared over my cosine squared. I'm like 1 minus cosine squared. What is sine squared over cosine squared? What is 1 minus cosine squared? You got it. All right, it is easy to get frustrated with these guys. It's not like clear cut. I can't tell you, you do this and this and this. It just varies from problem to problem. And there are different ways of doing it. Even answering questions today, I help people on problems, and there were some problems that we did 3 or 4 or 5 different ways because there's that many different ways to get there. Okay, so it really just depends on what you see. The important thing is you try something. All right, try something, see where we're getting to and what we can do with that. So what we're doing today, no new strategies, we are just practicing. There is a handout on Classroom. You are not doing all of it. Okay, so your assignment is 1 through 6 and 9. Now, if you want to do more for practice, that is totally up to you. But these are the ones that you will be turning in. Really focus on using good notation, showing all of your steps. Make sure, make sure you are boxing in a side. So some people have been coming in and asking me a question and I'm not even sure which side they're working on. So box in something so I know this is what I'm trying to get, this is the side I'm working with.